two-sample z-test for proportions using Excel. This is a typical problem. In a survey of 460 drivers from the South, 394 wear a seatbelt. In a survey of 380 drivers from the North, 293 wear a seatbelt. At alpha equals 0.06, can you support the claim that the proportion of drivers who wear seat belts is greater in the South than in the North? And we're to assume the random samples are independent. You always start by stating the null and alternative hypothesis here in math forms. The claim was that the proportion in the South is greater than the proportion in the North. The alternative thus is HA P1 greater than P2. The null has to be the complement P1 less than or equal to P2. And again, HA is the claim. Because the claim, the alternative, has a greater than symbol that points to the right, that tells you this is a right tail test. Excel does not have a built-in test for the two-sample z-test proportions, so you have to construct one manually. Instead of doing that though, in your calculator package in this assignment, you will find a number of calculators. This is the two-sample z-test for proportions with x given. There's another version of it in which you are given the proportions in the samples, but in this example we were given the counts, the x's. You enter your x and n's in the blue cells. You enter your significance level. Whenever you're running a z-test for proportions, you have to check to make sure that the normal approximation is appropriate. This calculator does that automatically, and here you can see that all of the required checks come up green, which means we can proceed with the test. The calculator gives us our sample proportions, p hat 1 and p hat 2, and also our estimates of the population proportions and 1 minus PQ, which you need to solve this. It gives us a test statistic of the difference in the sample proportions of 0.855, standardizes that test statistic to 3.194. Then you have to make a decision, and the calculator will give you the critical values for the two-tail, left tail, and right tail tests. Here, this is a right tail test, so the upper critical value is calculated as 1.55, and if you compare that with the standardized test statistic, you can see that the standardized test statistic falls well to the right of the critical value. That would tell you to reject the null. We also have a p-value of 0.0007, which is much less than our alpha of 0.06. That also tells you to reject the null.